Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. We've all been asked to help with an ad hoc request for data by the sales and marketing team. Then it becomes a critical report that they need updated every week or every day. Then what do? Send a CSV via email? Write some Python scripts to automate it? But what about incremental sync, API quotas, error handling, and all of the other details that eat up your time? Today, there is a better way. With Census, just write SQL or plug in your DBT models and start syncing your cloud warehouse to SaaS applications like Salesforce, Marketo, HubSpot, and many more. Go to dataengineeringpodcast.com/census today to get a free 14-day trial. Your host is Tobias Macy, and today I'm interviewing Prabhat Jha and Jonathan Ellis about Astra Streaming, a cloud-native streaming platform built on Apache Pulsar. So, Prabhat, can you start by introducing yourself?
Sure. Hi, this is Prabhat Jha. I head the engineering for Astra Streaming here at Datastax.
I'm Jonathan Ellis. I'm CTO at Datastax, and I work on streaming with Prabhat.
And Prabhat, do you remember how you first got introduced to data management?
I got into data management by accident, actually. After working for JBoss for a while, I decided to do a startup. And that startup was related to mobile application performance monitoring. So think like a New Relic, Datadog for mobile apps way back in 2011. And when we launched it, we realized that we're getting like these metrics and logs from like hundreds and thousands of devices every minute. And that's where like it really hit me hard that I had to store that kind of data volume and analyze it. And back then in 2011, it was like sending those data from mobile SDKs to the Amazon SQS and then basically processing those data and storing that efficiently, searching and all this stuff, right? That's how I got into it way back in 2011.
And Jonathan, how about you?
We were talking before the show started about jobs in college and how colleges don't have the budget to hire someone who knows what they're doing, so they hire students. And startups are kind of the same way. And so in 2005, a startup hired me to build a object storage engine, basically like S3, but specialized for backup data. And I was not qualified at all to do this, but they didn't have the budget to hire someone who was qualified. And so I got the job. That's my sales pitch for anyone who's thinking about joining a startup, is that you will get to tackle challenges that are outside of your comfort zone and outside of what you've proved on paper that you can do. And that was my entry into kind of the big data space.
Yeah, I can definitely agree that working at startups is a good way to kind of stretch your skill set because, as you said, you're going to be tasked with things that you never even knew were a problem until you have to try to solve them. And in larger companies, that's, the domain of some senior engineer who has all of the credentials and has all the experience so that they can just kind of bang something out real quick and not have to really do a lot of research or exploration. And early in my career as a sysadmin, there were a lot of things that got thrown my way that I had no idea how to tackle, but you just kind of figure out a way through it. And it's definitely a good experience. And so that brings us now to where you are today with Astra Platform. And I know that that's a new product that you're offering at Datastax, where Datastax has historically been a company built around Cassandra, and now you're adding Pulsar to the overall offerings. I wonder if you can just start by giving a bit of an overview about what you're building with the Astra platform and specifically Astra Streaming and some of the story behind how you got to where you are now.
The story there is that people have been using Cassandra with streaming use cases for almost as long as Cassandra has been, hit 1.0. And in particular, people use it a lot with Apache Kafka. But that's kind of a situation where, they use Kafka because there isn't a better option. In particular, there's a lot of friction with Kafka and Cassandra around the point that Cassandra is well known for being the best database in the industry to use if you need to replicate across multiple data centers. And Kafka doesn't do that. Kafka is a single data center architecture. That causes a lot of tension because you've got your system of record that is able to do this key architectural facility, whereas you've got your message bus that isn't able to do that. And so about a year ago, I started looking at this kind of the streaming space to see, is there another technology that Datastax could invest in that's going to be more synergistic with Cassandra? And that's when I found that, Pulsar has been around for about 5 years. It was open sourced by Yahoo and donated to the Apache Software Foundation. But around 18 or so months ago, Pulsar passed a maturity inflection point to where you can use Pulsar in production now and expect it to work without having to have, a committer on the team or someone who's digging into the code to figure out what that stack trace means. And Pulsar has a much more modern architecture than Kafka. So it's designed around separate compute and storage. It's designed around multi-tenancy. It's designed around handling both pub sub and queuing workloads, which we can talk about that later if that's interesting. So here's this thing that does geo-replication. It has all these other benefits. And so we acquired a Canadian startup called Kesk that had created a Pulsar as a service last October. And we've turned that into this new product called Astra Streaming that exists alongside our Cassandra as a service in the Astra platform as well.
And in terms of the streaming use case, what are some of the primary drivers for incorporating streaming with a Cassandra database and some of the overall product vision that you have for incorporating streaming into the Datastax offerings?
This actually comes back to what I mentioned earlier, that Pulsar does both PubSub and queuing workloads. And so PubSub means that you have topics that you publish messages to, and then you have subscribers that subscribe to those topics, and each subscriber gets or can read a copy of all the messages in that topic. And so it's kind of a fan out of those messages to anyone who's interested in them. Whereas the queuing side is more of, I want to send this message out to a bunch of potential consumers and load balance it across them. I only want it to be processed once. And so both of these are used in microservice-based applications where you don't want to have your microservices calling each other's APIs directly, because that takes the micro out of the microservice design. You're basically creating a larger coupled unit out of those services when they're directly coupled. So you decouple those by putting a message bus in between. And so that's where Astra Streaming comes in, is we have this Astra database that people are using, and it gives them significant advantages over using a system that only works on one cloud. So Astra is open source. It does hybrid cloud replication. If you want to run it on your own data center and as well as in the public cloud, you can do that. And we have a native cloud service for when you don't want to manage that yourself. So having both of the pieces of the stateful infrastructure that you need to run a microservice application on, the database and the message bus, that's significantly more powerful than just having one of those.
We are talking to a bunch of customers, and we realized that they had multiple system installed. Like for a streaming use cases, they could have Kafka kind of system. For messaging use cases, they will have like RabbitMQ kind of system or the JMS-based implementation, right? And ultimately, even though they're using different messaging system, data was being stored in Cassandra. So we're like, what is this platform that can solve these problems in one messaging system so that our customers don't have to install and manage and operate all of these things, right? It's a lots of complication to be able to manage this different architecture at a scale, right? We're looking for this kind of system. And that's where the advantage of Pulsar is that, it's easy to sort of migrate from your legacy JMS-based implementation and all this stuff into streaming based on Apache Pulsar. You can migrate your Rabbit MQ loads to the Pulsar. And of course, you can do the same thing for Kafka as well. So just as an organization where you're already flooded with like so many tools and systems and services that you need to build for your data warehouse, analytics, machine learning pipeline, it just helps you consolidate all into one.
And you mentioned that you had been doing some work with Kafka and that Kafka was sort of the only option for a while, but that there were some pain points. And you mentioned too that you had taken the time to revisit the overall streaming ecosystem. And I'm wondering what your initial criteria were as you were starting that search again to determine what technology do I want to bring in to complement my existing product and some of the potential other options that you were considering before you ultimately decided on Pulsar.
So we're looking for something that would fit well with Cassandra, which was kind of our starting point there. And so we're looking for something that's high throughput, that's low latency, that does replication across multiple data centers. I think those are kind of the table stakes. And then when I started looking a little bit closer at Pulsar, and I realized that they'd already designed in separate compute and storage and multi-tenancy, which are super critical when you're going to build a cloud service on top of something, that became part of my criteria as well. And I'm trying to think, but I don't remember anyone else that does all 5 of those.
Yeah.
And so, Pulsar is kind of in a class by itself in that respect.
Yeah, and also Datastax has made a bet on data on Kubernetes kind of architecture. So data, when you store, there's lots of work on running Cassandra efficiently on Kubernetes. We also wanted to make sure that the platform that we choose is cloud native. And if you look into the Apache Pulsar architecture, because it was only created in 2015-16 timeframe, Kubernetes was already there, right? And when we looked into it, it had a turnkey installation process for Kubernetes. So you don't have to reinvent this whole thing from scratch for it to efficiently run in a cloud native environment. And on top of what Jonathan says, I think the biggest thing is one of the important advantages is read and write path separation. In different messaging platform, if there's lots of writes, then the reads are affected. If you have lots of reads, then writes are affected. The new set of data, the volume of data keeps increasing. You want a system that can handle the read and write path separately. And Jonathan already mentioned that Pulsar has a separate way to do the storage, separate way to do the compute that also basically manifests into the read and write path separation as well. So I could have a subscriber which needs to pull the message that is in the system for last 1 month, right from the day one. This subscriber wakes up and start pulling the data. It will have almost no effect on the right path for the system, right? So those are the important platform criteria we had, because our customers who use a Cassandra to store millions and millions of records, they need this kind of a scale, and we just didn't find anything that could handle this.
And so in terms of the actual architecture that you're using for the hosting and management of this Astra service, I'm wondering if you can dig into some of the technical capacity that's necessary to be able to operate Pulsar at scale and integrate it nicely with the Cassandra hosting that you've already got available.
Pulsar is cloud native. It runs out of box with Kubernetes. It comes with a bunch of Helm charts that you can get going very quickly. So it has that built into it. But Pulsar had, other than the startup Kesk, there are not many known use cases of running Pulsar as a service in a multi-cloud environment where multiple people can use the same platform, right? So it's one thing to have a multi-tenancy built into platform, but if you're running that platform in your own data center for your own teams, that's a different thing. But if you're exposing outside to the world, all of a sudden the security concerns come into mind. The guardrails that you have to enforce to basically make sure that a noisy neighbor problem is not there. All the stuff that you have to think about when you're installing, when you're launching it as a service in the cloud. That's where basically we said, okay, let's look at the component of the Pulsar. Which of these brokers and bookies and zookeepers can be isolated, but can we run it in a way that if a customer has lots and lots of data, like we can still handle them without affecting the other tenants that is using the same platform. Because at the cloud scale, we didn't want to be in the business of installing separate Pulsar cluster for each customer. Then it becomes very, very expensive. So you have to think resource sharing, then security isolations and all the stuff. At the same time, if one or two of these customers have a really, really high volume usage, you want to be able to assign a sort of dedicated set of resources on that. And thanks to Apache Pulsar's cloud native architecture on Kubernetes, you could do this kind of assignments that some of these brokers and bookkeepers will be dedicated to like this customer kind of thing. Even at that point, you still don't have to launch a separate cluster for them, right? So those are the like one aspect of it. The other one was like guardrails. So, if you're a developer, sometimes you can accidentally flood the system. So, right, imagine somebody writes a script and that ends up creating like 1,000,000 topics, like for the tenant. Like that will be a very bad thing, right? So we basically went through almost like among broker configuration, bookkeeper configuration, and zookeeper configuration. There is like thousands of combinations of things you can do, and you don't know which one is going to hurt you in the long run, right? We actually went through the exercise of looking at each configuration one by one, which one we need to enforce guardrails on, right? So, when you sign up, obviously we don't want you to create like 100 like tenants. We don't want you to create 1,000,000 topics. So how many of these you can create? Another aspect, as your clients start sending data to the platform, it's possible that, you are sending lots and lots of data to our platform, but the subscribers and consumers are not there. So there's a huge backlog. We didn't want it to get to the point where we are like storing gigabytes of data for customers just sitting on the platform without getting consumed, right? So the guardrails around like how much backup storage you should have. All those kind of things came into building this control plane. And also because Pulsar's multi-tenancy, if you were running on your data center, you will be able to like admin the brokers and bookkeepers yourself. But in the hosted service, we are not going to give you access to the underlying infrastructure because it's a multi-tenant system. You are not the only one running on it, right? So these are the interesting exercise you ended up doing. So what we have is basically a Pulsar behind a control plane. And this is the one that is basically acting as a proxy for all the admin operations and things like that, so that we know what is happening. And because of this, we can monitor usage better and all this stuff.
In terms of the proxying and being able to filter the admin operations, but still be able to expose some of the necessary capabilities to the end user, I know that the open source project has an admin interface available to it. And I'm wondering what your approach was for either adapting the existing tooling or just using that as inspiration for building your own interface to the underlying Pulsar clusters that you're managing for your customers.
Pulsar has a great ecosystem. I know we talked a lot about the architecture and everything, but Pulsar has a very good ecosystem. There are lots of tools and SDKs built by community, which has been contributed back to the projects. And as part of that, they have also built these admin tools. But the difference was that Datastax already has this Astra DB as a service, which is basically Cassandra as a service, right? So when we launched Astra Streaming, and because it's for the same customer, we wanted them to have the same unique experience of like running database in the cloud. That same experience should translate into running a Pulsar in the cloud. So we had to do the authentication model, the authorization model, so that when you're logged into one, you don't have to sign in again. Like if you are a DB admin on Cassandra, maybe it makes sense to have an admin role on Pulsar as well, right? So those are the things we had to add on top of it. So it just didn't make sense for us to take what already existed with respect to admin tool and add that, because we had to redo it anyway. So the lots of work that we have done in Astra Streaming to expose it as a service has been on the actually control plane, where we do this authentication, authorization, rate limiting, some security enforcements, things like that to do that. So that's why we ended up building ours from scratch. The other advantage of the building our own configuration panel, because is that if you look at the people who are going to use Astra Streaming services, they're going to be different kind of a skill set. You could be a very strong Java developer who know about Pulsar a lot, but you could be somebody who have heard about Pulsar, who have heard about streaming, and you're trying to see how it's working for you. Those users who are going to require lots of hand-holding. So we wanted to build that experience that basically cater to both users. So if somebody coming up, we wanted you to give you the fastest way to get started with Pulsar. Because it's multi-tenant, for example, you literally sign up and in less than 10 seconds, you created a tenant, everything that is needed to start with Pulsar, right? I think those experiences we could not do without building from scratch.
In terms of the underlying operations of the system, obviously at the admin layer, you want to be able to restrict the overall functionality or capabilities of end users to be able to dig into the guts of the system. But were there any other modifications that you had to make to the Pulsar brokers or the bookies to be able to propagate some of those restrictions down through the different layers because of the way that it was designed and implemented as an open source project that is primarily intended to be executed within the confines of a single organization?
One was definitely related to configuration, right? So even though Pulsar has the brokers and bookies, as you mentioned, Tobias, and Zookeeper, we didn't want it to expose that directly outside our customers, right? So there is a lots of security rules around that. So for example, Astra Streaming is available on multiple clouds. So it runs on AWS, GCP, Azure, but the control plane is only on one cloud because you need to have a central control plane. So now I have a control plane running on one cloud, and this Pulsar cluster is running on multiple clouds. So we wanted, for example, the control plane to be able to talk to the data plane on different cloud securely, but without end user being able to do the same thing. So all these networking securities and firewall rules that you place between the Kubernetes clusters running on different clouds and all this stuff, like those were not easy to solve. Like we had to go through the guts and everything, right? With respect to underlying broker and bookkeeper and all this stuff, I think a lot of it worked out of box for us. The issue was more around like fixing the problems when it's under the high load, right? And when we launched, we didn't know how many customers we were going to get, what kind of workloads we were going to get, right? We were like testing for like hundreds and thousands of customers using this platform to solve their thing. As we were like flood testing the system with millions and millions of requests happening, like per minute and those kind of things, we found some edge cases like memory management, garbage collection, and all this stuff that you just normally would not find if you're not a heavy user of the system. So we ended up fixing those problems and contributing back to the community. Jonathan, you want to add some more to this?
The other example I can think of is around the Cassandra Pulsar integration that we wanted to do. So Cassandra, it's a NoSQL database. It's categorized in that space, but it is NoSQL database with the concept of a schema. So in Cassandra, your data is typed, and in Pulsar, you also have the concept of a schema. And you can evolve the schema, and you can have messages that use an earlier version of the schema. You can have the forwards compatibility with those. And basically, there was improvements we needed to make in how you could update the Pulsar schema dynamically and inspect it dynamically to make that going back and forth between Cassandra and Pulsar seamless. Because one of the most common things you want to do is you want to take Pulsar topic of events and dump those into a Cassandra table with some light filtering or maybe some light transformation. But fundamentally, for every event in the topic, you want to generate 0 or 1 rows in the table, or possibly multiple tables. We support that as well. And going the other way around as well, you want to take a change log of changes to a Cassandra table and put that onto a Pulsar topic. So we made some improvements around Pulsar schema handling. We contributed those to the Apache project, and they landed in the 2.8 release, which came out last month.
In terms of some of the other tooling and sort of monitoring and logging aspects of running Pulsar as a service in a multi-tenant, high-scale environment, what were some of the extra bits and pieces that you had to engineer to sort of scaffold the overall Pulsar environment that you're running and be able to ensure that your mitigations for noisy neighbors are effective and be able to identify users who are coming up against their quota limits and be able to offer them additional scale and capacity when they need it, and just some of the other operational and tooling aspects of being able to provide a robust end user service?
When we obviously launched these services, as I said, Pulsar comes with a cloud native setup itself. So when you install Pulsar out of box and that you get from community, it comes with a bunch of Helm charts, which has a Helm chart for like Prometheus, Grafana, Alert Manager, everything built into it. So you're like, hey, I have everything. Why do I need anything else? Well, those only work with one cluster and not at this scale. So that's number one. Number two was that we needed to do the true monitoring of the system. So what we have built is this open source project called Pulsar Heartbeat. It really basically sits outside the Pulsar cluster and it's sending a synthetic workload like every second just to make sure that the latency across the brokers, the bookkeepers, and everything is working fine. So it actually sends a message on a topic. It creates topics on the fly. It creates consumers on the fly and measures the end-to-end latency, right? So that's how basically we know that which cluster on which cloud is working well or not, for which tenant and all this stuff. As new tenants get added to the system, as new topics get created, as I mentioned earlier, we enforce a bunch of guardrails around it. So somebody's getting closer to the system, obviously we wanted them to know that they are getting closer to the limits that we have enforced in the system. But then we also had to build a mechanism that we can override to those configurations for selected customers, right? So those are the additional things we ended up adding into our control plane to do that. We didn't have to modify underlying Pulsar for these kind of things because we have a control plane in front of it, right? And that's also the beauty of the Pulsar as an open source project, and it's a very, very stable project, right? So what we realized that there were some enhancements needed to be done on security aspect of control access for the guardrail, but the underlying bookkeeper, the way the deployment architecture, everything works in a cloud native environment is fairly good with Pulsar. So we didn't have to invest a lot on that. Of course, there are some significant differences when you're running Kubernetes on Amazon versus Google Cloud versus Azure, and we had learned some of those. One of the, for example, features in Pulsar, it comes with tiered storage by default. So what tiered storage does is that you will have hot and live data in the memory, but then you can offload your historical data back to the S3 or the GCP storage or things like that. So that was super important to us because now we don't have to buy lots of expensive storage for our customers. So what we have enforced, for example, is a policy that anytime the backlog reaches certain threshold or a certain threshold with respect to the time and the size, it automatically goes to the S3 backup, right? As a vendor, our cost to support each customer is minimal because we are not storing all the stuff. This allows us to do the scale very efficiently because we all know that Amazon S3 and GCP storage, everything scales very efficiently. So you can have Amazon data as is coming, but we are not paying that much extra for that. So that was another thing we turn it on by default for you. And that is another advantage of doing that as a customer. You know that you're not going to lose data. We have the tier storage on, even if your subscribers wakes up 1 week later or decide to add a new application that needs the historical data and everything. Like there's no data deletion. Everything is stored over there, like by default.
Since Prabhat mentioned Pulsar Heartbeat, this is a good time to point out that as part of developing Astra Streaming, we've open sourced as much as possible of the tooling we've created around Pulsar to run this service. So Pulsar Heartbeat is open source. Our admin console is open source. And our Helm charts are open source. And we've taken these, not only did we say, hey, it's open source, good luck, we've actually bundled them together into a distribution of Pulsar that you can run on your own infrastructure if that's what you want to do, with the included Heartbeat, with the included admin console and so forth.
Yeah, there's hardly anything, Tobias, in our stack that is not open source, so that we have not given back to the community. So that's a strategic approach we have taken, is that we are not just thinking of open source as a dumping ground of things that we have done in secret and just go there. All of the things that Jonathan mentioned actually have been in open source from day one.
And if you want to find that distribution of Pulsar, it's called Luna Streaming. So Astra Streaming is the service, Luna Streaming is run it yourself.
And then in terms of some of the other sharp edges, you've mentioned a few different edge cases that you've run up against as far as being able to handle multi-tenancy and being able to scale it, some of the bugs that you found, but what were some of the sharp edges that you've had to kind of sand down as you started to scale up and add in more customers and start to have to support such a wide variety of different workloads that obviously you weren't going to be able to come up with on your own because customers always do strange and wonderful things?
So when I started looking into Pulsar, I was talking to one of my friends who knows both about Kafka and Pulsar. And he described Pulsar as it's a beautiful system architecture. It's designed by great system architects. But I think the people who actually programmed it were like not great programmers. And what he meant by that is that if you look at the API and all the stuff, it's not that intuitive. It's like, okay, this API works this way, this other API doesn't work this way, right? And I'm a huge freak when it comes to the developer experience of the platform. So just running into those gotchas when you're trying to interact with Pulsar as administrator using the API, and we wanted that to be consistent. We ended up making lots of fixes around that. One example, for example, is that in Astra Streaming, as well as in Apache Pulsar, you are able to connect to different destinations. Like, so you can send data to Pulsar topic and it will go to the Elasticsearch. It can go to the Cassandra. It can go to the various systems that exist out there. So one trivial example is that when you upload the Elasticsearch configuration, for example, and if your configuration is not good, you don't know until the data comes to the topic and it tries to connect to the Elasticsearch, right? Which is not a great user experience. You want to know if the configuration is not correct. You want to know right away, right? So those are the things we ended up fixing in our streaming services as well as upstream, I think, as well already, where this user experience of like coming to the platform and being able to get started quickly with the infrastructure you already have, whether it's the Elasticsearch or different kind of systems, that's where we also ran into some issues that we ended up fixing.
At a higher level, we went to market, we launched Astra Streaming beta, and we said, hey, come build applications with Pulsar. And in several respects, the Pulsar API is a step forward from things like the Kafka API, where Pulsar builds in asynchronous publish and subscribe events. But nobody wants to take an application that's working against Kafka or it's working against the JMS API and rewrite that to use Pulsar. So it's fine for, hey, I'm building something new and I'll start with Pulsar, but it's a tougher sell for, hey, you should rewrite your code so that you can use our new service. One of the things that we've been investing in is improving Pulsar's Kafka compatibility. So there's a Java client for Pulsar that implements the Kafka API. And so we've contributed some improvements to that. But we have also spent a lot of effort making it so that you can just take a Kafka connector. So you have a connector to Elasticsearch, or you have a connector to MongoDB, and send data back and forth between those systems without writing any code. You can take any of those 120 plus connectors that exist for Kafka and drop that in Pulsar, and it's able to use that to talk to any of those systems. So that was also released in Pulsar 2.8. So that's something that we're fairly proud of, driven by our experience with customers that we're giving back to Apache.
RudderStack's smart customer data pipeline is warehouse first. It builds your customer data warehouse and your identity graph on your data warehouse with support for Snowflake, Google BigQuery, Amazon Redshift, and more. Their SDKs and plugins make event streaming easy, and their integrations with cloud applications like Salesforce and Zendesk help you go beyond event streaming. With RudderStack, you can use all of your customer data to answer more difficult questions and send those insights to your whole customer data stack. Sign up for free at dataengineeringpodcast.com/rudder today. Yeah, that was going to be one of my next questions, is the sort of migration story for people who have an existing Kafka workload, because I know that there are a few different compatibility layers. There's the Java API that you mentioned. I also know that the folks at Stream Native have added a protocol adapter to Pulsar for being able to speak the Kafka protocol for clients that aren't using Java as their implementation language. And then there's also the Pulsar IO set of libraries to kind of mimic what the Kafka connector Connect project was doing, but native to Pulsar. And so it's definitely interesting to hear that you have adapted the existing Kafka Connect libraries to be able to work natively with Pulsar as well. So I'm wondering if you can maybe just spend a bit more time talking about some of the technical challenges and implementation details that you've had to go through to be able to manage those migration paths for people who were already using Kafka and want to migrate to Pulsar. That's
a little deeper than I can go. We can definitely introduce you to the engineers who wrote that code to talk about that. But actually, so Andrei Yegorov, who worked on the Kafka Connect piece of things, he gave a talk at Pulsar Summit about that. And so he does go into like, here are the impedance mismatches that I ran into and had to find a way around.
As you're building out the Luna distribution specifically, maybe some of the considerations that you have for what to include and sort of the feature comparisons that are available for people who decide to choose the Luna distribution versus the Apache open source version or the Stream native distribution, or if there are any other sort of distributions that are out in the ecosystem that you're tracking for being able to help people with that selection process.
Yeah, our goal with Luna streaming is to give people a batteries included for my friends in the Python community. That's one part of Python's philosophy is we want to give you, when you download Python, you don't need to download a whole bunch of other stuff. Python is batteries included, and you can be productive with what you just downloaded. And so that's what our goal is with Luna streaming as well. And so that's why we've included the improved monitoring tools, the improved admin tools, the improved Helm charts. One thing that's unique about Luna streaming is it smooths the on-ramp for people who haven't already bought into the Kubernetes world. Kubernetes as the foundation of both our streaming and our database technology. But I think everyone recognizes that Kubernetes is the future of operations, but it isn't the present everywhere. And so if we are saying, hey, to use Pulsar, you need to spend a week installing Kubernetes first, that's a big obstacle to some people. And so we partnered with a company called Replicated to give you basically Kubernetes in a box as part of Luna streaming. And so it will lay down a Kubernetes environment. If you point it at a cluster of 3 machines or 9 machines, it will lay down a minimal Kubernetes environment on those machines or on those VMs, and then install Pulsar on those for you.
Yeah, and I will add that something similar for Astra Streaming. I know I mentioned a lot about guardrails and enforcing the control plane and everything. What we didn't want to compromise that underlying what you are getting is Apache Pulsar, so that all the other toolings and frameworks and SDKs that exist in the open source and that's built by community or by different vendors, those should work out of box. So when you sign up for Astra Streaming and create a tenant for yourself, that is no different than creating a tenant for yourself on your local running Pulsar. So the existing tools like Pulsar CLI, performance tool, and the ecosystem of the connectors and everything, we do not, those things will work out the box for you. Obviously, with Astra Streaming, we want to make sure that connectors we support are tested heavily and it works out the box, and we can give you a peace of mind with respect to how it works. But on the Luna streaming, if you have a connector that works with open source Pulsar, those will work with Luna streaming out of box. You don't have to do any modification. I say with respect to licensing as well, there's no restriction. Everything is Apache license. There's no open core and this and that, all the stuff that you see here. At enterprise, peace of mind that you're getting is pure, truly open source software.
The other thing that we do with Luna streaming is, let me characterize it this way. If you want the newest, hottest features in Pulsar, then you should get the official Apache Pulsar distribution. One of the things that we're trying to do with Luna streaming is give people something that moves a little bit slower. And in exchange for that slowness, we do more testing and, we backport fixes as necessary so that when we have, Luna streaming 2.6.2, we pulled in some fixes that would appear later on in Apache Pulsar 2.6.3. And there wasn't a Luna streaming 2.6.0. We waited until it was, as stable as possible and then released that. So that's kind of in the enterprise market that Datastax serves, that's what they're optimizing for, is more the peace of mind than the latest and greatest.
And especially around security and stuff, right? So, as you could tell, our customers are like big enterprises, Fortune 500 companies and stuff, and they have their own security process. So lots of those kind of finding, whatever they end up finding, we end up fixing like early in Luna's, we end up fixing those and Luna's streaming as well as contributing back to the community. So, there's some sort of like a ecosystem, this thing going on between Luna and the open source Apache Pulsar.
And another element of the Pulsar ecosystem and the Pulsar project that we haven't touched on yet is the Pulsar functions capabilities for being able to do ad hoc event-driven execution of arbitrary code on the different messages within the topics. And I'm wondering if you can just talk through some of the tooling and user experience enhancements that you've been able to build in around how you manage the packaging and deployment of code to be run in these functions environments, and just some of the operational challenges of executing arbitrary user code in your managed service.
On the Pulsar functions, for people who don't know, is that you can write your own custom code in supported languages, which is Python, Java, Golang as well. I'm not sure how good the Golang support is, but definitely Python and Java, and we test that quite a bit. So idea is that you can push an arbitrary piece of code that will act on each message on a topic. And then that piece of code usually is for like message transformation, validation. You want to enrich that record in the topic with something else, you could do all this stuff. So Pulsar function is the underlying platform powering a Pulsar connector ecosystem. So when we run a Cassandra connector, when we run Elasticsearch connector, actually underlying mechanism is through Pulsar functions, right? So it is a first-class citizen of it, right? The question is, when you have a hosted platform, the managed platform, and you don't know the developers who is pushing code to it, like how do you enforce the security and the guardrails around it, right? That's a very, very difficult thing to do at a scale, obviously, as you could tell. So in Astra Streaming that we have right now, we don't allow you to upload custom code right now. We are working on that path where it will be available, but it's not that difficult either, because what happens is that because we run a Pulsar on Kubernetes cluster, and we can tie the Pulsar functions to a pod in Kubernetes, right? So what we are working on is that you upload your code and it runs in one of the pod that is assigned to your namespace. So you can do whatever you want to do. If you want to hurt yourself, you're going to hurt yourself. It's all in that pod, right? Pulsar architecture, because cloud native aspect of this, makes it relatively easier for us to support this. But having said that, we still have not done it because we want to make sure that the networking aspect of it. So we don't want anybody to write code that can sniff around the record for somebody else's topic and all this stuff. So we're still working on that, but I don't think we are very far from that, because the underlying cloud native architecture and the way it runs in Kubernetes, we will never run, for example, this Pulsar functions in the process, JVM process itself. Apache Pulsar allows you to configure where this runs, whether it's in the process, same process, or on the same node, or in a different pod. We are not going to do the same process, same node is going to be the pod thing, where we can enforce some security around it and make sure that it works.
And then one of the other pieces that you call out in the marketing material on the Luna homepage is the ability to perform machine learning on streaming data. And I'm wondering if you can just talk through some of the use cases for that style of application and some of the supporting systems that are necessary to be able to power that execution and the capabilities that Pulsar has natively that make it a tractable problem for you.
Yeah, when we talk to lots of our customers and my own personal experience at that last startup, one of the use cases of using queuing and messaging system was to build this machine learning pipeline, right? Where you have a bunch of data coming, you want to update your model, you want to serve the model and all this stuff. In Pulsar itself, through Pulsar functions, you can run Python code and Java code, as we talked about, right? Some of our customers have already done, when they use Apache Pulsar for machine learning, they're using Pulsar functions with TensorFlow if they're a Python shop. There are a couple of examples of customers using deep learning for J in the Pulsar functions if they are like a Java shop, right? So when I think about machine learning with respect to messaging system, you have a bunch of data coming up and you need to create a model. That means that each record in that topic likely needs to be cleaned. Somehow it will enrich with some of the data. So imagine a record comes in, you have some information about customer or event in that payload that needs to be enriched with something in Cassandra. So with that, which you can basically, in the Pulsar, you're not talking to three different systems. Basically, you can chain different Pulsar functions one step after another. So imagine a Pulsar function where a function does the transformation, second does the enrichment, and third one is actually sends the data to your system, which is updating the machine learning model on the fly, right? So we don't have a fixed way to basically, describe that this is how you should do machine learning. But usually, if you look at the least common denominator on the machine learning pipeline, is to clean the data in different steps and Pulsar functions and appropriately chaining them, you can create this ML pipeline easily. And we don't have to maintain yet another infrastructure. And because you are running the Pulsar function in the Pulsar itself, it's always up to date with the latest data. You can enforce schemas on it, right? So there's a schema drift on the topic, your Pulsar function will not work, and you will know that issue right away, right? The other things in Pulsar architecture that allow you to help you do that, obviously, when it comes to the serious machine learning use cases where your model is huge and everything, probably you would not use Pulsar functions for that because it's a thing in itself. So in that case, your topic and Pulsar function would connect to that deployment somehow and do the message flow and everything. Yeah, but for lightweight machine learning pipeline and stuff, I think you can easily chain functions together.
And then going back to the overall ecosystem question, one of the other interesting pieces of having companies like Datastax and Stream Native and some of the other ones out there using Pulsar in production at scale and investing in it is that it acts as an accelerator for the Apache project itself. And so I'm wondering, what are some of the elements of the roadmap that you are most excited for, that you're working towards, and some of the overall potential that you see for the Pulsar project now that there is much more momentum behind it in the past, year or two?
This is another thing. We have a Pulsar Summit talk that people can refer to. It's an excellent half-hour talk on applying chaos engineering to Pulsar. One of the things that we're focusing on is reducing that time between, hey, there's a .0 release and it's stable. We can build a Luna streaming release on top of this. We're leveraging a set of tools that we built for testing Cassandra called Fallout. We open sourced those a couple years ago, and now we're applying them to Pulsar as well. And so basically, the idea with Fallout is that you can declaratively specify scenarios that you want Fallout to apply either sequentially or concurrently to a distributed system. So in the Pulsar space, we can be, adding bookkeeper storage nodes at the same time a zookeeper node fails, at the same time as we're adding a new tenant and a bunch of topics, at the same time as an existing tenant is sending 100,000 messages per second through the system. What happens when you start composing these scenarios together, and can you find any, misbehaviors that you need to fix?
And that puts me in mind of the Jepsen project with Kyle Kingsbury. I'm wondering if you or anyone else in the community has engaged with him to do some of that type of stress testing and sort of ferreting out the distributed systems design flaws that exist in Pulsar to be able to address them.
Two answers for that. So Fallout is built on top of Jepsen. So Jepsen is a closure tool, and to create new scenarios, you have to write closure. And so we said, we love closure, but it's not a super common skill set. So we created a domain-specific language that allows you to build these scenarios without having to go all the way down to closure. The other thing that Fallout does is it gives you, basically a CI service for running these. And so you can set, and it will generate reports and performance graphs and, all those things of doing a test run that you'll want to investigate what happened to it, later. The other answer that I think is super interesting here is there is an engineer named Jack Van Lightly who was hired by Splunk relatively recently, and he's applying formal modeling techniques to Pulsar and to Bookkeeper. So, Fallout and Jepsen, they'll allow you to run a whole bunch of different scenarios and see what happens. You can't prove that there's not a scenario that you didn't happen to run. And so what formal modeling does is it lets you build, a theoretical representation of the bookkeeper storage protocol, for instance. You can test it at a much lower level. It's also not a proof technique. It's not going to prove that the bookkeeper protocol is correct. But instead of testing, thousands of scenarios in a week, I can test, millions of scenarios in an hour. And so it lets me be much more exhaustive about my confidence that the bookkeeper protocol is correct. As part of the work that he actually did find a bug in the protocol several months ago. We were able to fix that as a community. And, so I think the combination of formal tools that are more commonly coming out of academia and chaos engineering that's coming out of, the very practical side of companies like Netflix, it's a very powerful combination for improving correctness of distributed systems.
In terms of the ways that your customers are using the Astra platform, what are some of the most interesting or innovative or unexpected use cases that they've employed?
I think the answer to most of those, like the generic answer, is they're doing crazy stuff with Pulsar functions. You can do arbitrarily complex things without having to stand up and manage a separate cluster because Pulsar is managing that for you, or it's incorporated into the same Kubernetes platform as Pulsar. One company, a financial services company, is actually using Pulsar functions for all the business logic for the transactions flowing through their system. And I guess one of the reasons that's so cool to me is that when you're a fintech company, you're super, super risk averse. And so these guys did all kinds of homework and to make sure that all the failure scenarios were spoken for, and then they went ahead and put it in production. So that would be my favorite example.
One of the funny example, actually, and this is not a real event streaming example, when we had first announced that we're going to do the Astra Streaming and it is event streaming platform, few people actually understood as a literal event streaming platform where like you have a video camera streaming the events and all the stuff. So when we launched the alpha version of, we asked, hey, what's your use case? I was like, I'm excited to try this platform to see how I can do live video streaming or not. And we're like, this is not the right streaming we're talking about here. That was sort of funny thing that we ran into as well.
Yeah. The joys of the challenge of naming things and the collisions of meaning that occur in the English language.
Yeah, by the way, if anybody has any recommendation of what you call it, please let us know. We have tried data streaming, that gets confusing with something else. We have tried event streaming. Obviously, as you saw, that was like something different. So we still don't know what is the thing that describes what we do here.
I don't think that there's a succinct way to put it, but there are definitely more verbose ways that you could add clarity.
Exactly.
All right. And then in terms of your own experience of building the Astra platform and onboarding customers and being able to support it at scale, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think just going through the guardrail process to enforce like what we would allow a regular user to do so that they're not hurting themselves and they're not hurting us. So it is a pay-as-you-go system. So when you sign up for Astra Streaming, you're not thinking about how many brokers and bookkeepers you need. We just charge based on data in and data out. But at the same time, we wanted to enforce that at the end of the month, you're not surprised by a huge bill because rogue process was sending a bunch of data and all this stuff, right? So just thinking through the process of what is the right guardrail, because everybody's use case is different, and how can we make this platform so that we can turn on these things easily for different customers. I think were the most difficult part, because the different configuration works differently with each other. So you have to make sure that the combination and the defaults that we give is correct. That was definitely a challenge. And with respect to user experience, actually, we are still learning about this because it's only been a few months since we have launched streaming as a platform, as a service here. The people who are coming to our platform, they have a different kind of experience. They have been using Kafka for a while, and they have heard that this Pulsar is a new thing. This really works well. They're coming from that background. Sometimes some of the people have used Pulsar for a year, and they want to see if they can have a managed offering because they don't want to do it themselves. And then you have a completely like a new set of app developers who are building mobile apps and web application using GraphQL and whatnot. And their understanding of a streaming system is very different, right? So how do you build a user experience where obvious things are obvious, but also the complicated things are also there in a way that it caters to both of them. That has been sort of the difficult balance for us to get it right. I don't think we have cracked the code yet. Like, what is the fine line between like hand holding you as you're brand new user to the system versus expert one? We're still working on that. And our design team does a bunch of interviews and everything to make sure that we got it right.
If I'm looking forward to like what are the next challenges, we touched on one of those around allowing arbitrary user code to run in Pulsar functions and how we plan to tackle that. Looking ahead longer term, I think it's going to be interesting to tackle streaming analytics as well as the raw foundation that Pulsar gives you. And you can do that kind of by hand with Pulsar functions, but it's much more involved doing it that way versus using something like Flink and Flink SQL. So do we provide Flink as a service as well? That's something that we're going to be looking at.
Yeah. And on the same line, as you know, Tobias, I've heard a few episodes about change data capture. And, this is a beast in itself. And if you have a Postgres and MySQL kind of database where everything is happening in one node and like you have all the logs and everything that you need to replicate to the system, it gets easier. But when you have systems like Cassandra, NoSQL database running on multiple nodes and there's no master concept of it, that means you would have to reconcile this change log into one place before you send that to the Elasticsearch or different kind of system. Getting that turnkey out of box. We are a Cassandra company, so we should know how to do this better, right? So just working on that, fine-tuning that experience that if you need to do the CDC on Cassandra, it's the best platform. And so those are the another things that we already have an offering already, but we're constantly like fine-tuning that as well. That has been a super interesting project for us actually here.
For people who are interested in exploring Pulsar and they want to be able to get it up and running fairly quickly, what are the cases where Astra might be the wrong choice?
Man, for people who want to get up and running with Pulsar quickly, Astra's the right choice, like for everyone. Well, I guess if you need Pulsar functions in July 2021, we don't have that yet. And so that would not be a good choice.
Yeah, that will be one reason. As I said, Pulsar ecosystem has 100 plus source connector, destination connect, sync connectors, and all this stuff, right? We're not sure that the quality of all those connectors are really up to the standard, right? So we only support limited set of connectors based on what our customers have asked for. So if you need to connect Oracle database for whatever reason, you won't be able to do that here in Astra Streaming because we don't have that. And those are the use cases I would say, if you don't have the features that you need, then of course, you're not going to use Astra Streaming for that. But if you know that you need Pulsar, I think the Astra Streaming is the fastest way to get started, for sure.
You've mentioned a few things already about what you have planned for some of the upcoming roadmap, but what are some of the other elements that you're excited to work towards in the near to medium term, both for the Astra project and also more broadly for the Pulsar ecosystem?
So as a service provider, we care a lot about both day one and day two experience. So of course, I talked a lot that this is the fastest way to get it started, but we also want to make sure that we give you the best service for day two operations with respect to monitoring, alerting, the failover capabilities, making sure that everything just works out of box and all this stuff. I think we're just starting on that journey as part of this. We give you Apache Pulsar as a service because we want you to consolidate your Kafka and messaging solution, queuing solution all into one. But then when you start using, we don't want it to have you to do 10 more different infrastructure things to make sure that it's working properly. So those are the day two things, right? You will see us working a lot on those so that you don't have to, when you come to the platform, it is truly good service. That's the one on the usability perspective. The CDC work that, as we mentioned, making it turnkey with the cloud database that we have is another one. And then also having a laundry list of supported connectors that works out of box.
All right. Well, for anybody who wants to get in touch and follow along with you and try out Astra Streaming, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get each of your perspectives on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I've been thinking about that since last night, since I saw the questions. I think building the data pipeline, the machine learning pipeline is just still very complex, right? You need to the data source, the enrichment, transformation, how do you connect to the different systems, the building machine learning model based on that. I think it still requires lots of hand-holding and gluing things together. I know that there are other vendors trying to make it consolidated, but when it comes to open source ecosystem where you can connect these streaming systems and the databases and machine learning model and all this stuff, I think that is a big challenge still.
I would say broadly across the industry, a big gap is around infrastructure that supports seamless deployment across multiple regions and multiple data centers. So we're trying to close that gap on the Cassandra side, on the Pulsar side, but there's still everything else, all the other stateful infrastructure that by and large is just starting to tackle that.
Well, thank you both very much for taking the time today to join me and share the work that you're doing on Astra and contributing to the Pulsar ecosystem. It's definitely a very exciting project and one that I'll be keeping a close eye on and probably play around with a bit myself. So thank you for all of the time and effort you've put into that, and I hope you each enjoy the rest of your day.
Thanks so much.
Thank you, Tobias.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.